Alright guys, how can we do this? Let's start. Next question. So this is a question we have, and this question says binary subaverage with sum. So you have given a array nums, integer goal. Okay. So return the number of non-empty subaverage with some goal. Oh, so that's how we can do this. So let's take this example and try to solve this, right? Okay. All right. Alright, so this is the question, right? How we can do this? We have this array, folder, like this, and goal is 2, right? So this is a subarray, right, which has sum 2. This is also a subarray, this is goal 2. Okay, sum 2. And is there any other? Yes, this is also a subarray, and this is also a subarray. Like 4 subarrays we have, which has sum 2, right? So how can we count these subarrays, right, guys? So let's say let's try this because it's a subarray thing, okay, with a condition. So we can put sliding window with this, right? So let's try here. 1 0 1 0 1. L is here, R is here, R is here. Is it sum is equal to 2? No, R is here. Sum is equal to 2. Yes. Okay. Then what we do L plus plus for this L here. It's sum is equal to 2? No. But what we do is we count plus plus in this case also. So count becomes 2. Okay. Now again R will go from here to here. It's sum 2? No. Now count will go from here to here. It's sum 2? Yes. So it's just 3. L goes here. Sum becomes, this becomes 4. Like this. So whenever L moves or R moves with sum is equal to 2, we count plus plus, okay? Else nothing changes. So I think that is the way we can count them. Let's try this. Let's try to code this, guys. Just a minute. Okay. So and n is equal to nums dot size, right? And then we have int R is equal to like this 0 into L is equal to 0. Okay. And L is equal to 0 also. After this, while R is less than n, what we do? First one thing is and sum is equal to 0. Okay. Now sum plus is equal to nums are, okay, like this. So if sum is equal to goal, in this case what we will do? Count plus plus, right? count plus plus, then while sum is equal to goal, okay, what we will do, sum minus is equal to nums L, okay, L plus plus and count plus plus. Alright. So should I should I do like this? I think because like this. So LR is there like this in this example. How count will go? So like this. Let me show you. Right. So L is here, R is here, count and sum. Sum is 1. Okay. R is here, R here. Sum is also 1. R here. Sum is 2. Okay. If sum is equal to 2 is there, then L. So if sum is equal to L, while this count plus plus, count becomes 1, L goes here, sum becomes this, okay, only 1 is there, right? Then L is here, right? L is here, okay, then R goes here, no way, R goes here, then we can sum, then L is what? L, if sum is equal to 2, then okay, while that so count plus plus will become 2, L goes here, then count plus plus 3, alright. So I should also consider this R, right? So where R can go, so that's R. The sum is 2, okay, L is there, alright. If sum becomes 2, right, then I need to check if it is next thing is 0 or what, right? So I have to take this R to next thing. Alright. What I can do, if sum, once it becomes sum, okay. So while before moving L, I have to move this R, okay. While nums R plus 1, okay, is equal to 0, till then count plus plus and R plus plus, alright. After that what I do like this. So because what I am doing here is, alright, now I think I can solve this. Alright, right, L is here, R is here, count is equal to 0, R becomes here. So what I will do, if this R plus 1 is 0, right, so what I can do, what I can do is R is there, so what I will do, R plus plus I will do, and this will become 1. So R becomes here, comes here. Okay. Now after this is not 1, so I will come into the next loop and count plus plus also I do. I will do count plus plus. Is it? Yeah, because sum is 0. Then I am going to from here to L, which becomes 2. Then I R 3. Then L is here. And then 4. That's the end. I think I should check this implementation. Right, after all of this, this is a while loop here. I have to return count, and in this while loop I have to do R plus plus also, because I have to move the R forward. And if R plus 1, okay, R plus 1 is less than n, okay, and this will be the condition, I think. Let's check it. Okay, one case is finding it, one is not. 0 equal is 0. So I should output 10. Expected is 10. Expected is 15. Okay. 15 so very alright. How can I do this, guys? Let's check it also. How can we do that? Here. Learning. We need to log in here. Okay. And somewhere with some, let's check this solution here first. What is he saying? And then
array. The array will be a binary array. That means it will be containing 1 and zeros in it, and it'll also be given an integer goal. Now your task is to compute the number of subarrays. Now what is subarrays? A consecutive portion of an array, right? So you'll have to compute the total number of subarrays where the sum is equivalent to this particular given goal. So let's pick up one of the subarrays. If I pick up this subarray, the sum of the subarray is 1. So this is no correct. So we are not sure whether to move L or whether to move R. We are in dilemma, right? So I know one thing for sure. As of now, I cannot figure out where to move L and R if I'm looking for a sum equivalent to the goal, because it's saying equal to. And why is the problem coming up? Because we have zeros. On removing zeros, the sum is not getting affected. That is where the problem is coming up. Okay, so we need to find a better solution. So I know that I cannot solve this problem to find out the exact sum equivalent to goal. Can I do this? Can I do this? Let's try to solve a different problem and see if I can figure out a sliding window solution to it. Can I figure out the number of subarrays where the sum is lesser than equal to goal? I know that the problem is asking you to find equal to goal, but I'll try to solve it for lesser than equal to goal. And again, I'll try the same method. Let's take an L, let's take an R, because we know this is how we deal with windows. We will take sum, my bad. We will take sum, and that can be initially 0, and we will take count, and that can also be initially 0. So where am I standing? I'm standing at this segment, so I can add it to the sum. Is that lesser than equal to goal? Is my very simple question to you. Is this lesser than equal to goal? It is. So can I say this segment is a valid segment? I'm like, yes, this is a valid segment. And if it is, increase the goal. Perfect. Now what is the next one? I'll take the R and I'll move it here. Now this is where you need to apply some mathematics. I'm asking you a very simple question. When you move it to here, you add it to the sum still stays as 1, and this is lesser than equal to goal. Now if the sum is lesser than equal to goal, even after adding an element, can I say that element individually can be a subarray where the sum is lesser than equal to goal? I can. So this element individually, so here you add it to the sum still stays as 1, and this is lesser than equal to goal. Now if the sum is lesser than equal to goal, even after adding an element, can I say that element individually can be a subarray where the sum is lesser than equal to goal? I can. So this element individually is a subarray, as well as this element can combine with the left element. So I can say I have two subarrays. I can say two subarrays where the sum is lesser than equal to goal. One is the 0 itself, one is the 1, 0. Agreed? So I add another 2. Okay. What is the next step? I'll move R. But the moment I move R, sum will not change. And the sum is still lesser than equal to goal. Why did that happen? Because the element in itself is not allowing it to exceed more than goal. Okay. So can I say this element individually can be a subarray? I'm like, yeah, can be a subarray. I'm very sure. Okay. Can this be a subarray? Can this be a subarray? Yes. So what I'm trying to do is, I'm adding this element, I'm trying to figure out how many subarrays this element can form with the previous valid answer. And that is 1 itself, 2 and 3. That's nothing but the length. So I add 3 more to the answer. Okay. Let's move on. So this is when I move on, and this reaches 1, and the sum gets updated to 2. Now this time what happened? The sum is still lesser than equal to goal. Okay. So I'm very sure that this element in itself is possible. If this is possible, how many subarrays can it form? I already have a valid segment. So 1, 2, 3, and 4. I can form 4, which is typically the length. Okay, perfect. What is the next step? Now this is when you start understanding. I'm going over here. The sum gets increased to 3. Now when the sum gets increased to 3, what happens this time is, I'm saying, hey, on adding this, no. You'll have to shrink. I want under goal. This 3 is exceed.
Okay, I think guys, I understand this, because we can count this for less than equal to the goal. Okay, count for less than equal to the goal, and then count for less than equal to the goal minus 1. Then what we can do this okay. So let's try to do this here. Okay, LR, while R is less than sum plus is equal to R. If sum is less than equal to goal, so what we do? We increase the count plus. Okay, then we count plus and okay, like this. Okay, I think this is the right column separation. here. Alright. So if sum is less than or equal to, then r plus plus count plus plus. If it is not, right? If it is not, sum is not, else while sum is greater than goal, what do we do? L minus minus, no, sum of sum minus is equal to nums of L and L plus plus, like this. Okay, then we count this. Okay, and after this count, this count here and count G, goal, right? So this is one. After that, what we can do? We put same method here, Control C, and rule V. New goal is again goal is equal to goal minus 1, and again the count will become count 1. Okay, into count 1 equal to 0, count 1, count 1, count 1, count minus count 1. We put it like this. Let's check what happens here. Oh, we have to r is equal to 0 again, and L is equal to 0 again also. Let's check. And sum also 0. Sum is equal to 0 again also. Okay. Runtime error. What? Why? Integer overflow. What? And sum is equal to, sum is there, right? Sum is there already. This while loop is set up, right? Goal is equal to goal minus 1 is there. Alright. Nums is there. What is going on? And L is less than R. Let's solve the case, I think. Wrong answer. Why? Goal is equal to, output is 1, expected 4, or 50. What? Count 1 plus.
Reading. So I'm like, okay, let's try to make a valid segment. So I'm like, can I just take it off? Take it off. If you take it off, the sum decreases and the L will go ahead. And now you stop. Why do you stop? Because this is less than 2, so you stop. Now when you're stopping, now you can definitely say that this entire segment is a valid one. This entire segment is a valid one, right? And can I say that this is one subarray, this is another, and this is another. I can. So I again have 4 subarrays. And you might have a question. Hey, wait. Did you consider this? We did. Did you consider this? We did. When we were standing at 0, when the R was at 0, I considered this. You remember? I considered 0 and then I considered this. When I was standing here, I considered this, I considered this, I considered this. I've already considered these subarrays. Perfect. Wow. Next, I'll take R and I'll move it here. So on moving it here, it's still valid. It's still valid because the sum is still lesser than equal to goal. So again, you'll add the length and this will be your overall count. And right after the step, what will happen is R will move out of the boundary and you will be stopping. So now I know one thing for sure. How many subarrays are there?
Okay, I think the count is different here. Count equal to count plus L R minus L plus 1. Okay, like this. Count plus is not equal to count 1 plus R minus L plus 1. I think it will work. Yeah, now it's working. Wrong answer expected is this. Okay, 0 1 1 1. Alright. Goal is 3. 1 2 1 2 1. Okay. Then 2, then 3. I am going as 4. Okay. Let's see. Let's try that now. Okay.
That is lesser than equal to goal. I know that. I know an algorithm to find it, correct? 0. Sums of R, I know it. And after this, I'll add it to the answer. Only if I can combine the while and the if check. If the sum by any means exceeds the goal, then you know what to do. You will be. So what I've done is, I've combined the conditional check with a while loop. Because if this is true, it will keep removing. And if it is not true, it will go ahead and add your valid segments. How many? One. You remember? We did see it was the count. It was the count that was added. And the count is R minus L plus 1. You remember? We always this. Once I've added this, you can do R equal to R plus 1. And the while loop can end. Over here, there is an edge case. Please make sure if, or not here. Please make sure if the goal is lesser than 0, you can return 0. Again, at the starting, I said the goal will be from 0 to n. I'm writing this edge case for a specific reason. You'll understand in the next step. In case your goal is under 0, because the elements in the array are 1 and 0, so you can never achieve any subarray where the goal is lesser than 0. But this case will come up when we'll understand. Okay, so I know one thing for sure. I have an algorithm that tells me how many subarrays for a sum lesser than equal to goal. What am I looking for? Sum equal to goal. Can I apply simple mathematics and say, hey, for this, the answer will be, I can call the function with the nums array and I can ask him to find how many are lesser than equal to goal. It will give me, right? And then I can subtract with how many are with goal minus 1 isn't. That will work. Because if I can get how many are lesser than equal to goal and how many are lesser than equal to goal minus 1, and if I can subtract them, that will be equivalent to goal. That will be, isn't it? And that is why I introduced this condition. Imagine if the goal is given as 0. Whenever you write 0 minus 1, this will be minus 1. And that's when this condition will come in. Isn't it? Can I apply simple mathematics and say, hey, for this, the answer will be, I can call the function with the nums array and I can ask him to find how many are lesser than equal to goal. It will give me, right? And then I can subtract with how many are with goal minus 1 isn't. That will work. Because if I can get how many are lesser than equal to goal and how many are lesser than equal to goal minus 1, and if I can subtract them, that will be equivalent to goal. That will be, isn't it? And that is why I introduced this condition. Imagine if the goal is given as, and then there's a while loop which is excluding something. Now overall complexity is big O of for everything. So this will be the most optimal solution. I'm not discussing the root.
Okay, let's put it into a function here. Private int f, which will take vector int and nums int goal, like this only, and put everything here. Like this. Control C, V here, return count, and if a goal is less than 0, return 0 in that case. Alright. And for this guys, what I can do is enter count equal to f of nums goal comma n, enter count 1 equal to f of goal minus 1 comma n, and after that we can return count minus count 1, right? And here this and we are taking and there is no need to count it here. Okay, again and again like this. Let's try to do this. Goal line. Okay, we have to n is equal to nums dot size. Okay, like this. Check again. Yeah, it's working here, but let's see if it will work here or not. It's a wrong answer for this only. Why it's a wrong answer? Let's try on this, okay? Okay. Do this thing. If sum is greater than goal, now we can put it all here inside this. And what we do in other else case here, count forget also. Okay, while sum is greater than equal to goal, like this, and r minus r plus 1, r plus 1. Okay, try this. Now try this. Oh, it's now working guys, and we have the fastest solution also. It's 100% okay. I think we are good to go from here. Right, we have done this question. There is some errors. And now again count number of nice berries. We can do this later. For that, just a minute. I have some work to do.
Just gonna out myself. Now I'm diving deep into the world of sex work, breaking down the shame and stigma, having raw, unfiltered conversations with women that make them pay. So today, stop it! We have the very cheeky Tommy. I can see why you make girls nervous. Is that like how you throw it back on them? To just like intimidate them into nerves?
Okay, I don't know why I did that, but okay. Let's start health matrix. Your number one reviewer and it needs no build. For the health matrix, I can hand you a ready to page structure so you are not building a table from scratch. Okay. Okay, before doing the Okay, let's do the next question now. 45. Count number of nice savages, right? Okay.
If you clench your jaw, there's a good chance that your pelvic floor is clenching too, even if you don't know it yet. You may be shocked to hear, and this may be the first time that you are hearing, that there is a very clear connection in between your jaw and your pelvic floor. Today we're going to be discussing what that connection is and how it all works together. At the end, I'll show you a simple exercise that you can do to help decrease your jaw tension and your pelvic floor tension. I'm Dr. Amy, DSA trained in orthopedic manual physical therapy, and I believe that movement is life, and you deserve both. So how do the jaw and the pelvic floor actually be related? Well, it's super interesting because we actually have different sections of our abdominal cavity. So your abdominal cavity or your abdomen is your body parts. You've got the head, you've got the ears, you've got the legs, down there, the arms are out to the side. So we're talking about everything that's in the center here. So you have the bodice, which actually demarcates in between the head and then the chest, which is where the lungs are. Then you have the diaphragm, which is your big breathing muscle down here, and that demarcates in between the lungs and the abdomen.
Okay, so let's do this now, right? Given an array of integer nums and integer k, a continuous subarray is called nice if there are k odd numbers on it. Okay, let's try to do this question. And yeah, this is case 3 here. We are asking, okay, if in a subarray there are k odd numbers in it, right? So if there are k odd numbers, means number of odd numbers is k. So how can we do this? Let's say every odd number we replace it with 1, okay, and every even we replace it with 0, right? So now what we are asking? We are asking every subarray with number of sum is k, right? Okay, so like this. So this becomes the goal and this becomes this. So this is just a reframing of the question. How do you reach this from here? I think you need to think about these things also, right? Like, okay, we have 1 1 this 2, okay, 1 and 1, all right. And what we can do is So what is this happening, guys, is so let's say L was there, R was, if it is odd, yes, 1, if it is odd, 1, okay, 1 added 2, right, 1 plus 2 is 3, because 1 is this, and 1 is this, 3, it is even, we left it, we don't do this, then we are here, 1, 2 and 3. If we encounter any even, then we go R is equal to L, like this, okay, then 1 plus 2, like this, R minus L plus L, like this, okay. I think there are two methods to do it, let's try both, I think. Alright, so int R is equal to 0, and L is equal to 0, and then is equal to nums dot size, and while R is less than N, right, if nums, okay, nums of R modulo 2 is going to be equal to 1, so it is odd, then what do? We count plus count into count is equal to 0 if number of sub is k, right, okay, so 3 is there, number of odd is okay, like this, number of odd element must be 3, if it is this, so if it is there, then number of odd is we can go like this, number of odd is less than or equal to 3, and number of odd is like this, okay, okay, so if it is even, okay, like this, if it is even, then what we can do, we go count of even plus plus, right, so while P of even greater than right, So how many events should be there? So we are not counting even, right? We are not counting even. Even is not in the picture already. Okay. So we are just counting odd. Equal to 1. Okay, so if count is greater than k, number of odd is greater than k, then in that case this condition will be this. Okay, so the while we can do like this also directly. While count is greater than k, in that case what we do, sum is equal to greater than k if nums of L, right, nums of L modulo 2 is equal to 1. If that's the case, we do count minus, okay, and L plus plus. Alright, like this. Okay, we are just counting them. Okay. Else answer, right? 1 is answer. 1 is into answer equal to 0. Okay. Answer plus is equal to R minus L plus 1 on first case. If and how many count of number and count plus number of odd. Okay. If nums of R modulo 2 is equal to 1, then in that case you have to do count plus, right? And answer is this. If count is greater than k, if nums count minus L plus, okay, answer is already there. And so okay, do like this only, private int f current k, and put all of this there. Okay, let's like this, and return count and k if k is less than 0, return 0 in this case. N is already there, so no need to do this. Return the answer, right? Answer, and here int answer 1 f of nums comma k comma n, and answer 2 is equal to f of nums comma k comma n here, and return we will return answer 1 minus answer 2, and here int n will be nums of size, right, like this, and we are returning this. Okay, lr oh, TL is there. Why? There is no R plus plus anywhere, right? Okay. R plus plus must be there. So I can. Okay. Wrong answers. I think there is small variations only. 3 output is 0. Okay. Expected at 2. In this case, 0 output 0. Okay. Output 0. Expected 16. Why I am giving up to 0 only? Oh, it should be k minus 1, right? Yeah, second one. I think now more than 2 should be working. Again TLE. Why so? Why is there? I think L plus plus should be in either cases, so yeah. Okay, output 1 expected 2, output 12 expected this. Now we are improving, guys, little by little, right? Because I think there is a flow in logic here. L is then count minus minus. L plus plus, okay. Count is greater than k. Here R minus L plus 1. Answer was 0. If I are modulo 1, then count plus plus. If count is greater than this k, then this R plus plus. I think I am doing correct things, but where is the wrong happening? Okay, let's ask this where I am missing things. Okay.
Congrats.
Okay, so you're underlining equivalent, you're using the slash window trick. Okay. Okay, however, slash you can sub operation bug if okay. Legend your loop adding answer before you actually evaluate the current element at R and before you have shrunk the window to make it valid. You consider very top of the loop, you are counting the size window before the new bounds are verified, which leads to mathematical error. Okay, so okay. We're processing calculate number of valid average ending at okay. R is like this. If like this, count plus plus shrink. Okay, I can do this. Just one thing was missing. That's what I was skeptical of, right? Okay, like this. So do we go like this now? Okay, it's working. Like we are one of the fastest now also, guys. So it's all done and dusted. After this we have this question called number of substring containing all characters, something like that, right? Got all three characters, like given a string S consisting of characters A, B and C, return the number of substring containing at least one query, all A with C. Okay, getting a string as consisting of character A, B and C return. Let's take this example, guys. Alright guys, let's continue this question. Right, so just a minute, we will do this question also, guys. There is no okay, so current command httpx right here first Alright, so what was the question here? Let's do the question first, which is what? Okay, number of substring containing all three characters. Okay, what happened here? Now let's question is You are given a string S consisting only of characters A, B, and C. Return the number of substring containing at least one occurrence of all these characters A, B, and C. Return number of substring containing at least one, okay, occurrence of all these characters A, B, and C. Okay. So let's take this example. Okay, and try to go through it. Right. Okay. So here we have this input A, B, C, A, B, C, and all these characters are A, B, and C, right? So substring could be like this, A, B, C. Okay, then A, B, C, then all of these substrings, right? Plus 3. So 1 plus 3 is equal to 4. Now we move from here to here. Just a minute. Okay, so alright guys, let's continue solving this, which is this. like okay, so when then we go from here, B we are here, right? BC is there, length is 2, so we move from here, BC all of them is there. So again we have 1 plus 1 2, right? 1 plus 2 is 3. Then again we go from here, C A B, then like this, 1 and 2, okay, 1 plus 2, 1 plus 1 is 2. Then again we come here, like this, okay. Then 1 is equal to 1, so for 7 and 3, 7 plus 3 is 10, which is the answer, right? So I think we will have a map here, just a minute, okay. Okay. Like we will have a map here, and that map can do everything, right? ABC, ABC, right? Like this, ABC, 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 ABC. We have this map, okay? So A occurrence of A is 1, B is 1, and C is 1, okay? L is here, R is here. Now whatever the length, length is 1 2 3 4 5 6, 6 minus R plus 1, right, which is 6 minus 3, or we can say anything like 6 minus R minus 1, like this, okay, like this. So which is 3, or direct we can say like 6 minus 2, which is the index, which is 4, right? So here this gives the answer as to 4. Then what we do, we make L here, okay, which what L will do for now, it will remove this A, okay. Now size is C of 1 is which is B1 and 1, right? This which is less, so we cannot increase the counter. So what we do, we increase this R here, right? R is here. Now again A becomes 1. Now size is 3, right? Then again we can do like, okay, 6 minus 0 1 2 3, which is 3, okay. This will give us 6 minus 3, which is 3, all right. Then again what we do, we move L from L here, see, then this becomes erases, all right. And after this erases, then again size is less, so we take this here, B becomes, then again size becomes 1, and after this again 6 minus 0 1 0 1 2 3 4, so 6 minus 4, which is give us 2. Then again we increase L here, which will this C becomes, then again 1 here, when R becomes here, then I think 6 minus 5 is 1, right? That's how we can count it, right? I think we should this is the simple string, so we can do a different string like A B B C B A C, right? How can we do this? Okay, this is our map. L here, R is here, right? So in this case A is 1, B is 2, and C is also 1, and we can count it as 0 1 2 3 4 5 6, right? Again 6, so 6 minus 1 2 0 1 2 3 is 3, okay, which is 3, 1 2 3 4 5 6 7, it was 7, right? 7, so it is 4. Then we move L from here to L here, which removes this, right? Which removes this, and then we size is less, so we cannot count, right? and now we increase L is same, we increase R is here. Now this will become 3. Now size is still same, right? We cannot count it, right? Now we again increase R here, which will give us A becomes 1. Okay. Now 7 minus 6, right? 7 minus 5, I think here. 7 minus 5 is 2. Then we increase L here from, if it is this will become 2, size is still 3, so 7 minus 5 again 2. Okay, and then we again L takes L as here, then still it is 1, so 7 minus 5 is equal to 2 again, and L becomes from here to here. Now this becomes 0. Okay, now R becomes here, and 7 minus 6 is 1, so total will be 4, 6, 8, 10, 11 string, which has A, B, C all, right? Let's count A, B, B, C, B, A, C. A, B, B, C, B, A, C. Okay. So one is A, B, B, C. Then all of these 3. This is plus 3 is 4, right? Then we have B, B, C, B, A. Okay, plus 1, which is 2. Then we have this B, C, B, A plus 1 is equal to 2. Then we have C, B, A plus 1, which is 2. Okay, and after this B, A, C, which is 1. So it's 11, right? It's correct answer. This is the way we can do this, guys. So just code this now, right? Like here, what we can do is s dot size, right? And int L into 0, int R is equal to 0, and while R is less than n. This is one case, and we will have a map also, like map of pair comma int is empty, and after that what we can have is this. Okay. There is no question of only control ABC. Okay, ABC only 3, right? What we will do is mp dot a plus plus, right? Oh, no, r plus plus. Okay. If mp dot size is equal to 3, okay, is equal to 3, then what we will do, we have a count here, and count is equal to 0, right? So count is equal to count, you want to count plus n minus r, right? Like this, and this will become, if it is not like this, and what we will do, okay, so this is first occurrence. Okay, then after counting it, what I will do, so while empty dot size equal to 3, right, while it is going on, what I will do, like okay, I can remove this, right? I can remove this while this is going on. What I can do is count plus is equal to n minus r, and after that count is done. Then after that I will move L, right? So first of all I have to remove the S of L, whatever it is, minus minus, it is S of R here, right? And after that what I can do is minus minus and L plus plus. Before that, if okay, if empty dot map of S of L, okay, is equal to 0, then empty dot erase S of L, right, like this. Okay, and after all of this, while I can do is R plus plus here, alright, and after this I can return count also. Let's check it, guys, what happens. I think it should work, but let's see. Yeah, it's working. Check it now. Oh, it's only beat 8% only. Okay. Is there any better solution for that? Can we come from behind? A B C B A C. A B B C B A C C A B. Okay. So B A C is there. Then every other string from here to left is part of this. So 4 plus which is 5, and we come from here to here, then BAC again, which is 1 plus 3 which is 4, 9, then BCBA which is 1, and then this 1 which is also 11. So look how it's different then. Now why my solution is so slow, guys? Should I check the solution also? I have done this because it's all accepted here. Just I'm checking the solution for it.
possible. This one, possible. So I again have 3. 3 plus 3, 6. Okay. This one, no. This one, no. This one, yes. This one, yes. Another 2. 6 plus 2, 8. This one, no. This one, no. This one, yes, because it has all the 3 characters. So 1. 8 plus 1, 9. So the answer will be 9. And this is what you will have to return. So again, what is the extreme naive solution that you can think of? I just did it. Try out all the substrings. This possible substring has all the 3 characters. Do I need to traverse any further? No, I don't need to, because even if I add B, even if I add A, those substrings which will be formed in future by adding will also be a valid substring. So can I say the moment I get a valid substring, every substring beyond this will also be valid? I can. So can I say if I get this here, I can straight away add 3 to my answer. I don't need to go ahead. I can straight away add 3 to my answer. And how I can do it? It's very simple. So you write down the index number 0, 1, 2, 3, 4, 5. The string length is 6. You figured it out at the third index that it is possible. Like A. It'll still traverse till the end, right? Because you don't have any valid combination where the break will be executed. This is a subtle optimization. I did it because I want to explain you the optimal solution. So I'm looking to optimize my previous solution. The previous solution was taking n square. If I'm looking to optimize, I'm definitely looking to go towards the direction of big O of n. The problem, and there are substrings. I know one thing. With every index, there are a bunch of substrings that start. With B, this is a substring BB, BBA, BBAC, BB, this, and then with this B, this one. With every character, there is a substring. There are multiple substrings that start. I'll do the reverse. I'll say, with every character, there is a substring that ends. With every character, there is a substring that ends. I can do it from the front as well, but I will do for the end, for a frontward implementation. You'll understand at the end. With every character, there is a substring that ends. What does that mean? With the C, I can say that this is a substring where this is the last character. This is a substring where C is the last character. This is a substring where C is the last character. This is a substring where C is the last character. Okay. So I know how to access every substring that ends at any given character. Okay. So now I'll try to figure out. Okay, listen. Just for the sake of understanding. If I'm standing at this B and I'm asking you, hey, what is the minimal length? What is the minimal length of the substring that has all the 3 characters? You will be like, this one. Again, please keep it in mind that you should be ending at this B. So you cannot take anything beyond this. You have to look before it. So I'm very sure that this particular substring has all the 3 characters, and this is the minimum window we can have. This is the minimum window we can have. We can have this minimum window. Can I say this is one substring, right? How many more substrings can I have? I cannot add in the front because I'm just looking for substrings that end at this B, that end at this B. So I cannot add it in the front, but I can add in the back. I already have 1. I can still expand it. The same logic that we did in the brute force, the optimization. I can do an expansion. So this is what I will try to do. For every, can I say this is one substring, right? How many more substrings can I have? I cannot add in the front because I'm just looking for substrings that end at this B, that end at this B. So I cannot add it in the front, but I can add in the back. I already have 1. I can still expand it. The same logic that we did in the brute force, the optimization. I can do an expansion. So this is what I will try to do. For every character, I'll try to figure out the minimum window. If I can figure out the minimum window, I know one thing. This is going to be 1, this is going to be 2, this is going to be 3. That's nothing but, if I write down 0, 1, 2, basically index numbers, this is the second index. And if this is the minimum, how many substrings can you get that has all the 3 characters, where basically it ends with this B. So ACB is 1, this is another, and this is another, correct? ACB, this one, and this one. So I have 3, which is nothing but index plus 1, 2 plus 1, 3, correct? Let's try to expand this logic, and let's see how I can figure it out. I'll tell you, don't worry. As of now, just understand what's my thought process. So what I will do is, I'll straight away take a hash map, and I'll keep ABC equal to -1, -1 equal to -1. Okay. And I'll start iterating. I'll write down the indexes as well, 0, 1, 2, 3, 4, 5. You'll understand, don't worry. Let's start iterating. Add the character B. First thing we'll do is, we'll update this. We'll say this is, the character B was last seen, this is very important, was last seen at the index 0. But tell me one thing. For B, if this is the last index, I'll have to look on the left, right, to get a valid window. And I don't see it because I don't have an A, I don't have a C. So I don't see it. Not an issue. We'll straightforward go to the next one. I again have a B. I just do one thing. I'll update this to index 1. But do I see A and C? No, it's still -1. So thereby 3 characters are not possible. Let's move ahead. That's an A. Update A to index 2. Perfect. But still, there is no C. So I cannot have a window. Let's go to the C. Now this is the moment you start understanding. You see a C and you update it to 3. Now tell me one thing. Tell me one thing. If you're standing at C and you have A, you have B, you have C, how do you recognize that this is the minimal window? How do you recognize that this is the minimal window which has all the 3 characters? You basically look over all the last seen values and you see that B is at the index 1. Thereby, if you start from B and currently you are at C, you'll have everything. Because if the minimal value is at B, A and C are after it. So I'm very sure at index 1, till this, it's a valid one which has all the 3 characters. Minimum possible window. This is a valid substring. And if this is a valid substring, I can add on every character to the left. I can add on every character to the left. And I can generate more and more substrings, which is ending at this particular character C. Okay, fine. How many do I get? I get 2. Very obvious. 1. My bad. I'll use the marker. Otherwise, it'll be messy. 1 and 2. Maybe a C and B a C. Perfect. What is the next step? I'll move the pointer to the B. First thing you'll do is please update B. Now again, you'll see that you have A, you have B, you have C. And if you have them, what you're looking at is, what is the minimal window? You look for the value of A, B and C, and you see that A is at the leftmost. A is at the leftmost. So A is at 2, that means this is the minimal window. And if this is the minimal window, this is a possible substring. You can add everything to the left. Thereby you can create, this is the individual 1, and you can create 2 more, 3, which is nothing but 2 plus 1. So you can just create 3 more. Perfect. The next you will do is, you will take this and you'll move it to A. First thing you'll do is, you will straight away update A to 5. And now you will ask, okay, ending at this, what is the minimal window? And you'll figure it out, A, B, C. C has the minimal value. So thereby, this is the minimal window. And if this is the minimal window, can I say this? That along with this, I can add this, typically 4 additions. And it is at index 3. So 3 plus 1, 4. And after that, what you can do is you can finish it off. And that is all. So if you add it up, you'll get 9. So what I did was, I did the same brute force. I tried to generate all the substrings, but in a smarter way. Standing at every index, I tried to figure out what is the minimal. You could have done it in the opposite way as well. Standing at the first, figure out the minimal on the right. For that, you have to traverse in the backward direction. That's why I took the opposite. You can do the opposite as well. Very simple, very clean. I'll take it forward is also last seen, and whatever is the value, again minus A, equal to the current index. Now please make sure that you have 3 of them. So you can just write a simple condition. If last seen, what is it, 0 is not equal to -1, and then for all the 3, that means you have 3 of them. And if you have 3 of them, what you do is, you say count equal to count plus 1 plus is whatever.
Alright guys, let's make this also fast a little bit, right? Faster solution. Okay, this was our solution, but there is a better solution for this also than this. Let's try to do that also, right? We have this an array of, we can say, vector, right? Vector of integer last is equal to like 0 1 3 comma -1 here, everything is -1, and then we have int n is s dot size, and we will have count, right? And count equal to 0. Then what we can do is we can for int I is equal to 0, I less than n, I plus, and after that we can actually like, okay, as there is a last, right? Last of, let me do it like for you, last of s of I, right, minus small a, okay, is equal to I. Now if s of 0 is not equal to minus 1 and like all of this, right? And control C, control V and control V. If all of them is not equal to minus 1 and 2. Okay, this, if it is all of them, then int index is equal to minimum of s of 0 comma s of 1 comma s of 2. Okay, and of s of 1 comma s of 2. Okay, and count this is equal to idx plus 1. Alright, and at the end we will return the count also. Let's check if it is working or not. Okay, all of them are wrong answer. Ooh. Count is equal to count plus index plus 1. Okay. What is the problem in this? Wait, it's not it's not S guys. It's about last. Okay, it's last guys. Okay, let's forget it. It's last guys. Last here also last. Here also last and last, right? I think it should work it now. Yeah, and it's order of n right now, and it should work. Rate 68%. It's one of the fastest solution, guys. So yeah, it's done and dusted. Let's move to the next question. What is maximum points? Okay, what it is? There are several cards arranged in a row. Okay. Each card has associated number of points. The points are given in the integer array. Just a minute, guys. I'll be back in a minute. Just let's do the question first. Okay. Okay. Just a minute. Condition.
मथुरा के छाता स्थित शेरगढ़ रोड की कांशीराम आवास कॉलोनी में आवास आवंटन को लेकर गंभीर अनियमितताओं के आरोप सामने आए हैं। स्थानीय लोगों का दावा है कि कई आवास ऐसे लोगों के कब्जे में हैं जो योजना के पात्र नहीं हैं, जबकि कई आवंटित मकानों पर वर्षों से ताले लगे हुए हैं और उनके आवंटी बाहर रह रहे हैं। दूसरी ओर वास्तविक जरूरतमंद गरीब परिवार अब भी आवास के लिए भटक रहे हैं। स्थानीय लोगों ने जिला प्रशासन से कॉलोनी के सभी आवासों का भौतिक सत्यापन कराने, अपात्रों के आवंटन निरस्त करने
emergency means
जनपद मथुरा की छाता में तहसील प्रशासन ने एक बड़ी कार्रवाई करते हुए सरकारी राशन के चावल से लगे 2 ट्रकों को
मूल रोड स्थित प्रसिद्ध हनुमान बगीचे परिसर में चल रही 7 दिवसीय श्रीमद् भागवत कथा ज्ञान यज्ञ के 6वें दिन शनिवार को कथा स्थल पर श्रद्धालुओं का जनसैलाब उमड़ पड़ा। दोपहर 2 बजे से शुरू हुई पावन कथा में कथा व्यास राधे राधे बाबू महाराज ने भगवान श्री कृष्ण और रुक्मिणी विवाह के प्रसंग का बेहद भावपूर्ण और संगीतमय वर्णन किया। कथा व्यास आंख में पहले ऊपर की जो पलक है ना उसमें इन्फेक्शन होएगा, तो वो पलक में इन्फेक्शन होएगा, दाने दाने से होएंगे। ट्रैकोमा टर्म का मतलब ये खुरदरा हो गया कोई चीज, तो पलक है ना ऐसे खुरदरी हो जाएगी, बाद में अंदर मुड़ जाएगी ऐसे ऊपर वाली आईलेट। अब अंदर की साइड मुड़ गई तो उसको बोल देते हैं ट्रैकेमाइटिस। उस टाइम आदमी जब पलक झपकेगा ना तो वो आंख के ऊपर रगड़ मारेगी कंटिन्यू, तो लास्ट में जाके इससे कॉर्निया डैमेज हो जाता है और आदमी परमानेंटली अंधा हो जाता है। अब अंधा हो गया आदमी शुरू बैक्टीरिया के इन्फेक्शन से होगा। अच्छा, ये स्प्रेड कैसे होगा? जिस आदमी की प्रॉब्लम है उसकी आंख का पानी दूसरे के लग गया तो हो जाएगा, नाक के पानी से भी हो जाता है। और ये जो है ये बच्चों में और औरतों में तो बहुत जल्दी फैलता है क्योंकि वो जो बार बार हाथ यहाँ लगा रहे हैं। तो दैट्स वाई जो WHO है, WHO बोलता है भाई इसको काउंटर करने के लिए तुमको सेफ SAFE स्ट्रेटजी लगानी पड़ेगी। ये S क्या है? सर्जरी। जैसे इसके अंदर पलक अंदर होने लगे तुरंत सर्जरी कराओ, वो काट के उसको ठीक करेंगे। इंडिया में इसको रोहे बोलते हैं, रोहे हो गया के साथ रोहे बीमारी हो गई। फिर A इज व्हाट? एंटीबायोटिक्स खाओ। F इज व्हाट? फेशियल क्लीनलीनेस, मुंह साफ रखो। E इज एनवायरमेंटल क्लीनलीनेस, चारों तरफ साफ सफाई रखो। तो इंडिया में से एज अ पब्लिक हेल्थ प्रॉब्लम अब इसको हटा दिया। पब्लिक हेल्थ प्रॉब्लम में से क्यों हटा दिया? ऐसा नहीं कि बीमारी इरेडिकेट हो गई, इरेडिकेट होना अलग है और पब्लिक हेल्थ प्रॉब्लम नहीं रहना अलग है। पब्लिक हेल्थ प्रॉब्लम नहीं रहने का मतलब है कि नए केसेस जो आ रहे हैं स्पेशली 15 साल तक की एज के जो है 1000 में 2 से कम आ गए हैं केसेस, तो हमने कह दिया पब्लिक हेल्थ प्रॉब्लम अभी नहीं रही। ऐसे ही एक कंट्री है फिजी, 2025 में फिजी ने भी बोला है कि भाई हम भी तोता जो है वो ऐसी आवाज निकाल लेता है, तो इस पे खूब से बच्चे मिट्टी में खेलते हैं तो इम्यूनिटी बढ़ती है। अब पता नहीं ये कॉन्स्पिरेसी हो रही है, क्या चक्कर है। पिछले कुछ सालों से ऐसे केसेस आ रहे हैं जो बच्चे मिट्टी में खेल रहे हैं, उनके HUS का प्रॉब्लम हो रहा है बीच में। अब HUS क्या होता है? हेमोलाइटिक यूरेमिया सिंड्रोम। इसमें क्या होता है कि मिट्टी में एक बैक्टीरिया होता है, बॉडी में जाएगा, ठीक है।
सच बताऊं तो भाई मैं दुनिया का सबसे अमीर आदमी हूँ क्योंकि मेरे पास एक ऐसी वाइफ है जो मुझे यहाँ से लेकर के इस नीचे जमीन से लेकर के और मुझे उस नीचे से आज तक ये सपोर्ट करते हुए आई है।
रोड पे चलना हर औरत
संकट तो लड़ना इतना हर्ट नहीं करता जितना उनका शांत हो जाना करता है, लेकिन रियलिटी ये है कि इसमें ना ही करनी आप।
Alright, let's do this question guys. Okay. There are several cards arranged in a row and each card has associated number of points. The points are given in the integer array. Okay. There are several cards arranged in a row and each card has an associated number of points. The points are given in the integer array card points करके. In one step you can take one card from the beginning or from the end of the row you have to take exactly k cards. Okay, your score is the sum of points of cards you have taken. Okay, given integer any card points integer k, return the maximum score you can obtain. Okay, let's take this example and understand this. What is this question trying to say, right? Let's do this here only, this, and okay, do this here, do this. Okay, so we have this example here, which is this array, 1 2 3 4 5 6 and 1, right, and k is equal to 3. After the first step, your score will be always be 1. Okay, yeah, either you take from left, either, okay, however choosing the rightmost card will maximize your total score, because this and this will be bar. Okay, like we can do this or this, like this, right? So we have to take only k characters. From one can take at one, like we can move from right to left, then we have, okay. So how can we, like, optimal strategy, take the 3 cards on the right giving I have to take the maximum, right, maximum score I have to build. Okay, so one is L, one is R, which is this. If I am coming L here, okay, next step, and so I think this could be like this, right? What I will do, so there is a window, right? I will make this a circular window. Okay, 1 2 3 4 5 6 4. 1 2 3 4 5 6 and 1. Okay. What I will do, this is 3, right? 0 1 2. I am in here, and I go from here, right? Add of all of these. What is this? 1 6, right? This 1 is 6. What I go, then I cut from here and I move here 1, then which is 4, then I move from here, I go here 1 here, this 1 plus 6 7 and 1 8, which is 8, then I cut from here and I am here 5, right? 5 6 1, which is maximum, 12, right, which is maximum. So I can do it like this. So this will take me order of k time, right, which is at least should be there. So it's not a very I think big of a okay. So what I can do is I can take the modulo thing, right? Modulo. So there will be int n is card points dot size, right, and I will have L is int L is equal to left will be like this, n minus k, right, kth index, int r is equal to also like this, okay, equal to n minus k. Okay, now what I can do, let me just verify this also, because I am not sure is this a true index or not, like this. Let me verify this. Okay, so 1 2 3 4 5 6 7 and k is 3, right, which will be 4. So 0 1 2 3 4. I think I am at right index, right? Okay, so I am at 4, 5, 6. This is fourth index, right? Okay, so I will at right index L is equal. Then I will take R here, this plus this plus this. Okay, when k is equal to 3, then what I will do, I will move L and R at the same time, right? L plus plus and R plus plus like that, and modulo also I will take. Okay, and I will reduce the k. Okay. Okay, let me do it. While L is less than N, like this. So when L goes here, then my R is here, right? Like this. L plus plus R plus plus. All right. Okay, let me go this out. Okay, so while L is less than N, okay, sum will be sum equal to 0, or infinite answer equal to 0 here. Okay, because we are finding max, or we can do like int min also as answer. Now sum plus equal to what is card points, right? Card points, are whatever the values. Sum is there. Okay, and one more thing, I have to count the window size also. Okay, window size. If R minus L, okay, R minus L, right? Check plus 1. R minus L plus 1 is less than equal to K. Okay, if it once becomes K, window size, right? Then what I will do is and answer is equal to max of sum comma answer, right? And so I have to take this value. This will become here. If a window become like, okay, okay. Then what I will do? I will do 1 L plus 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 also. Okay, here when it is here, and this will be modulo N. And after this, what I will do? R plus plus only one time, right? Alright. Answer is going to be sum of answer, okay, and this will become like this. K is there, and after this sum minus is equal to card points, right, of L, and I will do this. Okay. After all of this, I will have to return answer, right? Like this. I think it should work. Yeah. Wrong answer after the 125, 27. I have this. Just check what is the problem in this approach. Just checking. Okay. Missing combination. Check exactly k plus 1 combination. So then. Okay, 10. Okay. Okay, we are one of the fastest guys. है।